Hey Algebra, we're on the last chapter here and we did not get through the whole chapter, but this is what we did attack, and let's see if I can get this done. I actually have some people heading over here, so I'm gonna see if I can sneak it in, otherwise I'll finish this up later. So, all right. Chapter 12. First thing you want to take a look at here is vocabulary, right? Excluded values. You got to know what that is. Excluded values are values that you can't have. It's impossible. For example, you see a fraction before you, you cannot have a zero in the bottom of a fraction, right? Calculator explodes. So, well, it just errors actually, but you cannot have this bottom part be zero. So all you do is you take the bottom part and say, okay, well, what makes it zero? Because those are the values I can't have. Oh, I don't know. That looks kind of complicated. Oh, no, Mrs. Silva taught me that we can do GCF. So I see there's a C. So I'm going to factor out a C. Oh, and remember, I have C times this whole thing. So when you have two things multiplied together and they have to equal zero, one of the two things has to be zero. So either this is equal to zero or this has to equal zero. So what would make this zero when C is 8? Correct? So those are our excluded values. If we put a 0 in here, we're going to get 0 in the whole bottom. 0 squared minus 8 times 0 is 0. You put an 8 in here, we get 8 squared minus 8 times 8, which is 64. 64 minus 64, 0. You cannot have either. So there we go. Number 2, oh dear me. I will turn that distraction off. Okay, here we have a simple fraction. And again, you got to take note every time you have a problem of what do you have. Because most of these are simplifying. Even though you're multiplying, you're dividing, you're adding, you're subtracting, in the end, it all has to be simplified down. So when you start with just a fraction and you don't see any adding or subtracting, those are the simplest because you can simply look at the top and look at the whole numbers. We got a 12 and a 2. 12 over 2 reduces to 6 and 1. We've got an x and an x squared. So remember, that's an x and then an x squared. That's what that is. So one pair crosses off. So I'm left with 6 on the top and an x on the bottom. All right, next, color. So again, we look here, careful, careful, careful. The excitement over math jumps in at this moment and you see those 9s and you just want to cross them off. No, you can't. Okay, you cannot do that. This k plus 9, they're like married forever unless you get rid of them together. Okay, they're together. Same with these, they're together. You either cross them off with another k plus 3 or you don't cross them off at all. You either cross this off with a k plus 9 or you don't cross it off at all. And I see you're saying, oh, but there is a k plus 9. No, this term isn't k. This term is 3k. That is the term. You can't separate that. I can look and see if there's a GCF though, and that's what we're going to do. So on the top, I do see there is a GCF of a 3, and that's a terrible color to use. I'd like you to be able to see it. 3. And what's left when you factor out a 3? You get a k plus 3. All over, I'm going to rewrite this. Okay, now we have it together. So we have the k plus 3 and the k plus 3. Notice these are multiplied. Multiplied. So when you have entities that are multiplied, that you can cross off because everything's just multiplied and you're left with 3 over k plus 9. All right, then we get to this one. And again, don't let yourself do it. Don't let yourself say, oh, k and k cross off. Oh, the 5 and the 15, I got 1 and 3. No, no, and no. This k plus 5, there's nothing more we can do it. That's together. You can't separate it. This is together. The only way it can be separated is if you factor it. And there's nothing to factor up here, so that's just stuck. But this looks like a box 1 situation. So what plus what equals 2, and what times what equals a negative 15? So we start to think, what is that? Probably a 3 and a 5, and it's got to be positive, so I think it's going to be a 5 and a negative 3. Yep, that works, that works. So now I'm going to factor that bottom one out. So I have the k plus 5 top, and when you factor this, I'm going to get a k plus 5 and a k minus 3. And now we're getting rid of the whole thing together. So my answer, be careful, the k plus minus 3 is not up here, is it? It's down here. We can't just throw it on top. It has to stay in the bottom. So what's in the top then? A 1, not a 0, because if there was a 0, you'd have 0. There's a 1 up there. We just don't usually write a factor of 1 in these other things because we have other ones. We don't write 3 times 1, right? All right, so we're looking at 5. When we look at 5, again, oh, please, do not 5x and 5x. No, no, and no. What is married? The 5x and the minus 10, those are together. These, they can't be separated unless you factor out something. And we can factor out a 5. So if we factor out a 5, we end up with that, and then we end up with the 5x in the bottom. There's nothing more we can do there. But I now have 5 times this and 5 times x. So I can cancel those 5's out, and we're left with x minus 2 over x. All right, now let's take a look at number 6. Again, look, evaluate, analyze. When we had these, we had, fraction. No adding and subtracting. Oh, we got into adding and subtracting. We got to be careful. But there is a multiplication in between. Got the adding and subtracting everywhere until we factored. Then we got the multiplication. Adding and subtracting. And then we have factoring again. Here, everything's just multiplied. I mean, and we have the division, of course, the fractions. But we can go through here and now cancel. And this is the part you have to be careful of. And when there's so much, it may be easier to get all the letters to the right first because you start losing track. So I'm going to just do the numbers now. So I'm going to look at the top and say, okay, I got a 21 and a 28. So if I divide those both by 7, I get 3 and 4. And I got a 30 and a 25. If I divide them both by 5, I have 6 and 5. And then we still have more because we have 6 and 4. So I'm going to do that as well. That's 3 and 2. And just double, I can't go sideways. Okay, so only up and down. And so we're going to end up with 3 times 3, which is 9. 5 times 2 is 10. I'm going to extend that fraction because we're going to just put all those variables together in there. So when we have an m to the 4th times an m to the 3rd, what do we have? We have an m to the 7th. When we have an n to the 3rd times an n to the 6th, we have an n to the 9th. And then there's the p to the 15 still there. There's nothing to combine that with. Looking at the bottom, we have an n to the, is it a 9? Yeah, n to the 9th. And there's no more. I'm going to put it under that n to the 9th. P to the 4, I'm going to go put it under the p's just to keep it clear. Since they're all multiplied, I can put them in any order. M to the 6th. All right, now, we already did the numbers, but this makes it a little clearer, doesn't it? Because look at those n's. Goodbye. And then we're left with, let's see, 7 m's and on top and 6 on the bottom. So those 6 would cancel off with 6 of those, and we're just going to be left with 1 m on top. And let's look at the p's. We got 4 on the bottom and 15 on the top. So 4 of these will cancel with 4 of those, and I'm left with 15 minus 4, that's 11. And double check it, take a look, make sure there's nothing more, and there is not. All right, one moment please, I need to put a pause on this. All right, I'm back. So when we look at the top here, Yes, it looks a little bit different than some of these others, right? So we had multiplying down here, two fractions, no adding and subtracting. Now we are multiplying two, and again, I can do this real quick, two fractions, but we have adding and subtracting. So we have to be super careful. This one's, there's nothing to do there. We can just wait and see what ends up in the bottom. Maybe the 2 or the x will cancel with something. I don't know. Let's look. But what we can do is look at the bottom here. Can I do any factoring with that? And the answer is yes. What's the first thing I say to check every time? GCF, right? So if we look at this, we can factor out a 3, and we're left with an x minus 2 down there. And then this looks like a box 1 situation, so let's check that out. What, we got 4 and negative 12. So let's see here, probably 6 and 2 is my guess. It's going to have to be 6 and negative 2. And so we end up with, I'm going to rewrite this whole thing just to be super clear. So we have an x plus 6 and an x minus 2. Lovely, isn't it? Because these are stuck together, so are these, and so are these, but you can get rid of those too. So I end up with a 2x times x plus 6 all over 3. And just double check, you know, make sure there's nothing more you can do. And then remember at the very end, even though we had this, we broke it down to get parentheses. The reason we wanted parentheses was so we could cancel. But now at the very end, when we know there's nothing more we can do, we need to go ahead and distribute that again to get it simplified and get rid of the parentheses. So 2x squared plus 12x all over 3. And that would be the final answer. Now when you look at 8, I'm looking for a different pen. Where's my cool pink one? I think a thief in the house. Nope, I found it. We have a division. I'm going to use my pink one on this. We have a division going on. So remember, keep, and it's going to be change and flip. So before I start writing at the keep, change, flip, I just want to look in here and see what I have. Because these are all adding and subtracting, and so are these. So I'm going to need to evaluate each one of those parts and see if they can be factored. N minus 4 cannot be, but the top here I do see a GCF of 4n. And what is left then? If I take a 4n out, I have an n plus 2. So I'm going to rewrite that 4n times n plus 2 all over n minus 4. Keep, now I'm going to change and flip this. Okay, but again, I want to kind of factor at the same time so I don't have too much going on. So if I look up here, what can I factor out? 2, and what's left? N plus 2. So again, that's going to be on the bottom though, because I had to flip it. This looks like a box 1. What plus what equals negative 1. Be careful with your signs. What times what equals a negative 12. I think we got a negative 4 and a 3 here. Just double check. Yep, that works. So we're going to have an n minus 4 and an n plus 3 here. So keep, change, and then I flipped them. This was n minus 4 and n plus 3. And then I flipped them. Okay, now the fun begins, doesn't it? We get to go through here and see what we can cancel out. Well, the n minus 2 for sure is going to be gone. Let me see. Look at a nice bright green. N minus 2 and n minus 2 is gone. Oh, cool. N minus 4 is also there, so those are gone. I don't have any n minus plus 3 to work with, but I have a 2 here, and I have a 4 here. And these are multiplied, right? Those are all separate multiplications, so I can cross-cancel that. So what the heck do I have left with here? I have a 2n, what else? Times n plus 3. Be very careful to make sure you don't miss something. The bottom, yay, all gone. So we can just distribute those now and get our final answer. So 2n to the second plus 6n. There's nothing in the bottom, so I don't need to put it over 1. I can just leave it like that. Okay, get out of here, buddy. That is my husband. Stop it. All right. Again, we're supposed to get company. I think you're supposed to be starting the grill, aren't you? All right. So, new color. Okay. I'm going to do orange. No, I already did orange. Purple. That's what I haven't done yet. Purple. Okay. So we are adding now. So look at this, class. This is where everything shifts. And you have to shift. Your brain has to shift. You're doing an adding and subtracting. Highlight things if you need them to just like jump off the page at yourself. Get used to doing things that help you when you do tests. Start now when you're young. And when you get to college, you're going to be just expert pro. So when you look at this, again, any fractions you add have to have common denominators. Here, we kind of lucked out. We have common denominators, 8 plus 5. When you add fractions and they have common denominators, the bottom stays the same. So I'm going to end up with one fraction here. And resist the urge, because you're seeing this, aren't you? I know you guys are, because you're so bright, and you're looking here and you're like, but I could factor a 10 out, and oh, this is a box 1 situation. And you want to separate them. But remember, it's not helpful here because I can't cancel. I could cancel vertically, actually, if they worked out, so I could do that. But I can't do diagonally like I normally can. So we're just going to combine all that top stuff together and then see if we can factor with what we have left. So I'm going to look up here. This is plus, so these are all going to be the same sign, whereas the other one down here is negative, so I got to be careful because that switches both signs. So I've got, let's see, any other a squareds? Nope, just one a squared. And then I've got 20a minus 9a, so that's 11a. And then I've got 10 plus 20, and we got 30. All right, now that we've got one fraction, I've got one entity in the bottom, a plus 5, that has to go together or stay together. They can't separate them. So I'm going to do a box 1. What plus what equals 11, and what times what equals 30. And I'm going to get, let's see here. Looks like it's a 5 and a 6. I bet you guys are getting pretty quick at finding those, aren't you? So I have a plus 5 and a plus 6 on the top. I have a plus 5 on the bottom. Yay, those are multiplied. So I can cross off the a plus 5s, and I'm left with a plus 6. That, students, is fun. Yes, it is. Taking all this and doing all this work, and boom, you're left with that. It's just so much fun. Onward. Now we have to do the exact same thing, except two things are different. Number 1, we have a subtraction. We mentioned that earlier. And number 2, the bottoms aren't the same, the denominators. So I have to figure this out, and I see that there's an x plus 2 down here. But what you want to, at this point, I know up here we're like, don't factor, just combine. Well, that was because the bottom was the same. Here, I kind of got to see what I'm going to need to do to get my common denominator. So I got to look at this, and I see that this is a difference, subtraction, of 2 perfect squares. So this really is the same as x plus 2x minus 2. So when I have that in the bottom of one fraction, and I just have this in the other fraction, what's going to be the simplest way to make those two the same on the bottom? Right, multiply this by what? Well, what's missing? The x minus 2, right? So I'm just going to rewrite the top because I didn't change that one at all. That's exactly the same. But now I am going to change this one because I need to have an x minus 2 over here. So I'm going to need to multiply that by x minus 2 and the top by x minus 2. Then, yay, I'll have the same common denominator. I can put them together. Problem is, got to multiply those. And you know how to FOIL. So we're going to do that. That's x squared minus 2x. My eyes are like playing around with me here. I think I need new glasses. I actually do. Is 4x and minus 8. Or is that plus 8? No, it's minus 8. So when you combine, we see these two together, and those are going to be 2x. So we have x squared plus 2x minus 8 when you combine like terms here. So now let's put them together. The common denominator is x plus 2 and x minus 2. That doesn't change, it stays the same. And I have the top. So I have 2x squared minus 16. Now remember, this minus has to distribute to all three of them. So basically every one of these signs changes. So it becomes a minus x squared minus 2x plus 8. Combine like terms on the top. Let's see, we got a 2x squared minus a 1x squared. That leaves us with x squared. We have a minus 2x. And then negative 16 plus 8 is a negative 8. All over the same bottom. Box 1. So we're going to factor that. I'll go over here to do that. And I'll do it in a different color so you can see it. What plus what equals negative 2, and what times what equals negative 8? Looks like negative 4 and 2. Does that work? It does. So I have, I'm going to rewrite it again just to be really clear. X minus 4, x plus 2. That's what I just got right here. All over the bottom. X plus 2, x minus 2. And oops, I'm in the time here. Sorry. And then now these cancel. Now that they're multiplied, I can do that. And what am I left with? X minus 4 over x minus 2. That was a tougher one, wasn't it? You really got to keep your work clear and succinct so you know you don't lose track of what you're doing, because it's, okay, I need common denominator, but to figure out what that is, I had to factor. Okay, I factored. Now I know. Now I'm multiplying. But then I'm foiling and I'm multiplying together only to distribute and do, not distribute, factor to get it out again. So you're kind of going back and forth until you can figure out what works at. All right. Let's see, I got at least 3 problems so I can get, or 4 to get this out to you guys. All right, so the top one, we are dividing. And when we're dividing, you can, if it divides into all of them evenly, that's pretty slick. But otherwise, you can split this up and divide them each by this. So I'm going to take 8y to the 4th over, I'm just going to put this on every one. As long as I put it with each one of them, it's fair. I just can't pick just one. I got to put it with all of them. So I'm going to do that. Plus 2 over 4y to the 3rd. Now, simplify each fraction and you're done. So, all right, so this is 1 and this is 2. This cancels with these and you're left with just, the whole thing. You get a 2y. Actually, that's it, right? The 2, and then you just have 1y on top. So that's all you have there. Minus 1 and 2. And where's there a y? Oh, there's 3 on the bottom. So I have 1y in the bottom, so minus 2 over y, plus, and oh, we can factor here too, or not factor, simplify. So we're going to take a 2 out of both of those, and don't forget that that 1 has to stay up there because there's nothing left. So you just put a 1 up there, and then 2y to the 3rd. All right. Now, we keep moving. We're going to divide again. Actually, even though like 13 is that long division one, 12, you could use the long division one, but it's really also very similar to this one, isn't it? So there's kind of a little bonus there, because as long as you understood that, you can actually try it that way too. So this is a box 1. Let's see, what plus what equals negative 13. Let's see if it works. Otherwise, we will have to use the long division. 40, let's see, 1 and 40, 2 and 20, 4 and 10. Wait, sorry, I'm distracted. I'm like waiting for the doorbell to ring because they're going to be here at any second. So now my brain is not functioning properly. 5 and 8. Oh, 5 and 8. There. Okay. 5 and 8. So we want them both to be negative. And so we have b minus 5 and b minus 8 all over b minus 8. Yay. Done. All right. Then this is the long division one. And I'm happy to tell you what one it is. I want you to be super clear and careful. So the second part, of course, goes on the outside, divided by 2n to the second plus 6n minus 5. When you put them in, just lose the parentheses so it doesn't distract you. And then what you're going to do is look here and say, okay, what do you multiply n by to get 2n to the second? And hopefully you would say 2n. Now that goes above the n term. So I'm going to put 2n above the n term. Now 2n, we got to distribute now. 2n times n is 2n squared. Should be. These should be the same. 2n times 5 is 10n. Now remember, you draw your line, and just like in long division, you subtract. But you don't just put the subtraction there. You have to subtract that one too. So these cancel out, which they should. And you get 6n minus 10n is a negative 4n. Just like in long division, you carry down the next one. And we ask the same question now. What do you multiply n by to get negative 4n? And hopefully you say negative 4. So you write it like that with a subtraction. Negative 4 times n is a negative 4n. Negative 4 times a positive 5 is a negative 20. Draw your line and watch carefully. I have to go in now and subtract. And when I subtract, here, I'm going to subtract, right? But it's subtracting a negative, so what happens? It becomes a positive. Same thing here. I'm going to subtract here, makes it a positive. So basically both sides flip, and that's gone. It's just up here they happen to be positive, so they both became negative. Well, now they were both negative, so they both became positive. Negative 5 and 20 is 15. And now it's a positive 15, so I'm going to put plus 15 over n plus 5. And that is the answer. Right here. All right. And we have one more. One more. So we're going to solve. We're going to cross multiply and finish this up. Well, you could notice in this case they happen to be the same, so then the tops should be the same, so you could take the easy route. But I'm not going to take the easy route, just in case the one on the test is not like that. I'm kind of curious. I have the test here. I just want to look quick. Aha! The one on the test is not the same, so we don't want you to get in that habit of thinking it will be like that. Two fractions equal, it is a proportion. You are going to cross multiply. 3 times that whole thing. You have to distribute. X minus 1 times x plus 4. You're in a FOIL. So 3x plus 12 equals x squared plus 4x minus x minus 4. I have 3x plus 12 equals x squared plus 3x. I combine those, minus 4. I got to move those over, so I'm going to subtract 3x on both sides. I'm also going to subtract the 12 on both sides, and I'm left with x squared minus 16 equals 0. And now we have a difference of two squares. So 0 equals x plus 4 and x minus 4. So x would be equal to a negative 4 or 4, but you always have to look to see if there's extraneous values. If you put a negative 4 in here, does it work? Negative 4 plus 4, can't have 0 on the bottom. Get rid of that. 4 plus 4, 8, that'll work. Okay, so let's try 4. So 3 over 8. Let's just practice. I'm not going to do this one right now. I'll have to come back to that bottom one for future years here. But let's just practice. If you put a 4 in there, it's 3 over 4 plus 4 is 8. Is that equal to, let's put 4 minus 1, 3 over 4 plus 4, 8. Yes, it is. So my answer is x equals 4. So I hope that helped, and have a great day. Bye.